Thank you so much for having me. I'm really excited to be here to talk about this. It's a really a bit of a departure from things I usually talk about, but I think this content is really important for us to kind of understand and comprehend. So I'm going to ask you to take out a piece of paper if you have one, a notebook, pencils. If you doodle on an iPad or have a tablet, do that. I'm really impressed to see that none of you are really on your laptops that often, which is cool. That usually doesn't happen at a tech conference. But just hold whatever you have with you. Maybe you'll feel inspired to write or draw or illustrate, take notes, like pass notes to your friends. Doesn't matter. Just take it out, have it out. You don't have to take detailed notes here, but just have it with you. So as you heard, my name is Yuna. This is me on the internet. You can find me at UNA on Twitter, GitHub, CodePen, on all the things. I have a lot of different demos and work out there. And then you can find more technical blog posts on my website, yuna.im. But this is one of the conference themes of ColdFront this year, which is software is more than just code. And this is a really true concept that we need to kind of understand. Your software is nothing if nobody knows about it or how to use it. So in this talk, we'll learn about how to share information and how to effectively communicate that to the technical community, how the way that we currently communicate is broken based on our biology, and how we can do better. So I'm going to teach you how to learn and how to teach, and how technical diagramming can make your products more approachable and more successful. So let's start with Redux. Who here has heard of Redux? Most of you have heard of it. All right, hands down. Who here uses Redux? Like maybe a third of the people here. Redux is a pretty technical concept, right? Or at least it sounds that way. The name alone makes some people's pulse speed up a little bit. And the fact that it's a state management system, that just sounds complex. Like I can't even manage my own schedule. According to the website, Redux is a predictable state container for JavaScript apps. And here is the gist of it from the website. The whole state of your app is stored in an object tree inside of a single store. The only way to change the state tree is to emit an action, an object describing what happened. To specify how the actions transform the state tree, you write pure reducers. That's it. Got it? If you look further into the documentation, it even emphasizes this point by saying Redux itself is very simple. And that's true once you understand the basic concepts, but when you start looking through this page, does it seem that simple off the bat? If this is your first time diving in, other than code examples and a little bit of typography changes, there's not much here helping us understand what's going on. And compared to most documentation sites, this is actually really nice. This is actually a nice one to look at. It's beautiful. But does anyone ever feel like this about docs? Sometimes you get excited to dive into this new technology, and then you open up the docs, and then this is like my every weekend. But now let's take a look at another way of explaining Redux. Redux is a state management system. As you can see here, an action is invoked on the page. There's a proposal. She says yes. Then that action speaks to a reducer. Here we have the reducer Robin, who knows the language of nature that then can convey that information to our tree here, the state tree, in a language the state tree can understand. This tree is also the store, which then updates the knowledge and the state of the application. This explanation is a little bit non-traditional, and it might have some gaps, but it's more welcoming, it's more intriguing, and it's more likely to capture your attention and help you to learn a concept. From this, a user can see the simplicity in the concept and can then dive in more to some of the technical aspects of getting started. A little bit later in this talk, we'll go over some more of that psychology of why examples like this help you remember. It helps someone to paint the big picture for them, and then allow them to zoom in and paint the details one layer at a time. There's also something else for them to relate to. There's this other metaphor, which helps explain a concept by taking it out of its own unique space and bringing it into a space that your user can already understand, something they already have some experience with or know about. Most modern development concepts really aren't that complicated when you dig in. They just appear complex because most docs are intimidating blocks of text. They're just blocks of text, maybe a code sampler or two. And nobody likes to read big blocks of text. It's just what we're used to. But we can do better than that. We can do better. So in this talk, we'll discuss the psychology behind human memory and understanding, creating effective documentation and tutorials, tips for basic schematic modeling. We'll talk about some tooling, so some tools to kind of help you with your diagramming. We'll talk about examples of how diagramming can improve outcomes, and examples of how diagramming can also improve your own internal comprehension. And then we'll also talk about the benefits of doodling, which I think is a really healthy habit that more people should, indulge in. DevDoodles is a series of mnemonic devices and illustrations of technical concepts that started as an experiment in proving this idea that technical diagramming doesn't have to be boring. It's on Instagram at dev_doodles if you want to follow along. There's a lot more on there. And I'll kind of go over a few in this talk. But the doodle in that first example about Redux is just one of many that I've been working on as a means of helping me better remember concepts and then sharing how I remember those with other people. And so this can be technical documentation. It teaches the same concepts, but it doesn't have us feeling like this all the time. Like all the time. It's got to let it play out. I love this GIF. Adding any visual illustrations can be a great way to improve documentation, but technical documentation is so much more than that. It helps you learn and internalize that information. It helps you teach information, which reinforces that learning. It helps you unbundle your thoughts so you're not freaking out about all the things out there. It helps you discover bugs in your technical flows, and it helps document more clearly, which increases product support and adoption. So, this is a great start, but it doesn't have to be all that technical diagramming is. This can also be technical diagramming. So let's get into some human biology and how we interpret the world around us. Who here is really good at remembering things? Nobody raised their hand. I'm the same way. Who here is not good at remembering things? Yeah, most of us. Who here wants to be better at it? Everyone. With all the things going on in our field, it's hard to remember all of them. It's true. Our brains are really, really fascinating systems that work surprisingly similarly to computers with limited memory banks. The popular theory is that we have three types of memory. We have sensory memory, we have short-term or working memory, and we have long-term memory. There's also this visuospatial scratchpad. That's how we deal with navigation. Like if you're walking down the street and you close your eyes, you still have a sense of your surroundings for a few moments. There's also a phonological loop which relates to our speech perception, both externally, how we hear, and internally, what we're saying to ourselves. And that lasts for about 1 to 2 seconds. So let's demonstrate sensory memory. Sensory memory, as you guessed it, relates to our human senses. If I was up here on stage spinning a rope, right? If I'm spinning that rope faster than our sensory memory bank, which is about 100 milliseconds, it looks like a full continuous cycle. It looks like there's a circle right in front of you that's really light, depending on how thick the rope is. But if I spin it a little bit slower than that bank, maybe 120 milliseconds, then you'll see a gap in that sensory memory. You can visually see that because it's our visual sensory memory. We have that with all of our senses. The next type of memory I want to talk about is short-term memory or working memory. There have been studies that have said that we can hold about 5 to 7 different types of items in our short-term memory at any given time. So here's one of them. I'm going to give you 10 seconds to remember this phone number. All right, got it? Now what was the 4th digit? It was 9. When you were trying to remember the 4th digit, did you start reciting the entire phone number in your head, the entire sequence in your head? Yeah, that's because short-term memory is stored and retrieved sequentially. So you likely had to think through 5, 5, 8, 9 before you got to the 9. The final type of memory is long-term memory, which flows through sensory and working and is then encoded in one of 3 ways. This is what we hope will happen when we're going through video tutorials or blog posts. Does anybody ever wish they were Kirby? I wish that I could do this. What if these were service worker syntax knowledge? What if this was programming tips and tricks? How cool would that be if you could just absorb all of that knowledge and become an expert? It's more like this, though, am I right? Long-term memory is stored and retrieved by association. So the benefits are that it can be retrieved by a variety of means. We might discover a bug that reminds us of another issue that we've had before, or an architecture challenge that we know how to solve, or we know how to start to solve because we remember scanning a blog post about a similar topic once upon a time a little bit earlier. So the 3 ways that we encode this short-term into long-term memory are through visual and acoustic means and also semantic meaning. So we can remember things just from seeing an image or from hearing a sound, but the primary encoding system for long-term memory is semantic encoding. This means that the best way to encode something in our long-term memory is to understand the meaning of it. And there are a few ways to help us understand that meaning. The more that we repeat specific information, the more likely it will eventually end up in long-term memory. That's why studying or having more experience in the tech field helps us to perform better. People also tend to more easily store material on subjects that they already know something about. And this is because it's easier in our heads to make connections with existing items. Someone who has a pretty average memory might be really good at a specific subject because they already have a lot of background information on it. So you can have these people that have average memories, like all of us here. We might be really good at one specific thing. We might be experts at a certain field because it's easier to remember other things that relate to it. Most of the time when we forget something, it's really that we weren't focused when we were encoding it in the first place. We might have gotten distracted or we weren't really paying that close attention. And that's a really, really common phenomenon. So focus and attention are also key when you're remembering things. A part of our job is expressing our tools and our work to others to keep them focused and to help them understand what we're building. Without that, the impact that we can have as developers is really limited. And we're going to be reliant on other people to get the word out about our work. Most of us don't have the privilege of working with technical copy editors or developer evangelists to help our product move forward. It's usually just us. This is us in the open source community telling people about our repo and our application and our idea, trying to get other people to work on it with us. So understanding how humans understand is a really good skill to have as a developer. People have a few different modalities of learning, and depending on the individual, certain modalities work better than others. There are 5 common modalities that correlate to our senses. There is visual, auditory, read-write, olfactory, which is smelling, and kinesthetic, which is like physical feeling. Humans, being primates, are also visually dominant animals. Have you ever had the feeling of like meeting someone and like thinking, I know this person, I just can't remember their names? This is a really common, normal human phenomenon. Don't worry, it's not your fault. You're just human. Don't feel bad. We dedicate a really large part of our cortex to processing visual information. So here you can see like all that green area in the back of our brain. This is the primary visual cortex and visual association cortex. Next to that, moving a little bit forward towards the front of the brain, is the reading center. This came later. It's further away from the core of our brains. Names, and even written language, and especially code syntax, are all human constructs. But vision is something that we use for survival that's been developing as a part of our human anatomy for far longer than our ability to understand written language. The first written language is commonly understood as being Sumerian, which was a purely logographic language that was dated to around 5,000 years ago. And according to a few different studies that I discovered on Wikipedia, of all places, there are suggestions that the first spoken language developed around 350 to 150,000 years ago, around the same time that Homo sapiens evolved in the first place. So language, auditory language, existed before our version of human even existed. But we've had written language for, at the most conservative estimates, only at 3% of that time. So auditory language has been around for way, 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 way longer than this. So again, I ask, why does most technical documentation still look like this? Why do most textbooks still look like this? It's an easy default that we're used to, but it's not the best solution. Let's go back to learning styles. When we try to pigeonhole everyone into the same learning style, which is often how the school system works, it's pretty detrimental to individual success. If someone isn't good at reading text and memorizing facts, we're creating this like inaccurate idea that they're just not smart, that this isn't for them. And that leads to having similar people in the same fields, like tech. I'm not sure if you've heard about this, but I heard that tech has a little bit of a diversity problem. And the way that we share information could be a contributor to this. When we share information in only these massive blocks of text, only a certain type of learner can really excel at this type of understanding. And that creates sort of a technical monoculture, like an information bubble. But what if we diversified how we share information? Who would be interested in tech and building new applications and hardware? What kind of users and backgrounds and skill sets could we bring to the table to improve our products? We don't even know. What is universally true, regardless of what kind of learner you are, is that combining modalities helps anyone improve their comprehension of a subject. So you should try to combine as many of these as you can. If we go back to this idea of how people have evolved, not only was vision something vital to our survival, but audio was too. If you saw something like lurking in the bushes, you would use vocal communication to let your tribe mates know about that. We have stories and fables that were far predated to any written language, and not much has really changed since then. Sorry, this is dark. If we look at the brain visual again, we can see that there are not one, but 3 regions of the brain that relate to auditory input for different tones, for low, mid, and high-pitched tones. And we have a separate region of the brain for speech input as well. Humans are much more adapted to retaining information via visual and auditory input than we are to retaining information in text form. I didn't realize that I was an auditory learner until I started listening to a lot of podcasts. And I realized I was comprehending information a lot better that way. I could listen to them wherever I wanted as well. I think a lot more people are auditory learners than they realize, but we're just so used to the default of reading and writing that we don't even think to include that as a part of how we learn. So this realization, along with wanting to create a more accessible experience, is the reason that for my personal blog, Una.im, I started recording all of my blog posts as audio, so that this way people have an option. They can read, they can listen, or if they really want to grasp the concepts, they can read as they listen. So the option is out there. And then people really liked it. When you make an experience more accessible, it improves the experience for everyone. And while not everyone is an auditory learner and not everyone uses a screen reader to read the web, combining modalities helps everyone to learn better. So again, try to incorporate as many of these modalities as you can when you're providing technical information to another person. All right, let's talk about some visuals now. So this is a pretty awesome example of a blog post about insertion sort by Vaidehi Joshi. And what I really like about it is how she combines all of these different mediums here. So she's combining hand-drawn notes and GIFs and is really explaining this concept in a variety of ways. It allows for our eyes to move along the page, and it really holds our interest that way. It lets you scan images and notes that are physically written along with text. That means that we can see patterns, make connections on our own. Visual aids and having a variety of these different visual aids is super helpful in not only getting your information across, but also just keeping your user engaged and on the page. They're not going to click away immediately because they're bored. So let's break some of this down. As you can see in layout A, it's much harder to scan this information. It's a lot less interesting than in layout B, which uses a few of these techniques to make people feel more engaged. It uses hierarchy, content breakdown. We have chunking of content, so having small areas of little bits of content instead of one massive block of it, and a variety of media here as well. These are the different types of media you can use: images, illustrations, diagrams, photographs, video. Video is a really good medium for kind of explaining how something works. Interactive code samples. These are a really good way to feel like your user's hands-on, like the closest they'll get to hands-on before actually implementing the product they're using for themselves. Diagrams are really good for general concepts, and then explainer text paired with code samples can be really effective for deep dives about technical content. There's a lot of different typographic techniques you can use as well: style, layout, color, sizing, white space, different call-out sections. Putting a little bit of effort into how we're presenting our documentation can make a really big impact. So create visual movement. Think about this GIF when you're writing your blog posts and articles, and include diagrams and images. But images don't even need to technically be traditional images. Emoji are a great example of creating emphasis with minimal effort. Emoji can make certain text stand out. So this is a premium feature for Twitter that brands can pay for, to add a little icon to a hashtag. And it's an example of bringing a user attention to a topic, in this case a specific hashtag, by providing a visual pair. You're combining 2 inputs, reading and visual cues of imagery, to really make that stand out in your timeline, have the user pay attention to it. Another fun fact is, if you do include images along with text in Twitter or any other sort of medium, anything, blog posts, you are going to be more likely to capture users' attention and have them actually read what you're writing and saying. I love seeing emoji in Git commits too, because it helps you to visually parse and understand information. Adam uses this key when writing commit messages. This way, when you look at the log, you can see when bugs were fixed, how many, what type of feature they followed. You can see when tests were added or performance was improved just by looking at these icons. That would be a lot harder to parse if it was just blocks of text. But if you could see some kind of visual icon along with that text, it's easier to work with. And this is especially true once you get used to working in a system. You can work pretty fast and also just have a lot of visual input to help make your life easier when looking at logs. And that brings us to symbols. If I show this image on the screen, what does everyone instantly think of? Monopoly. These are what I like to call universal symbols. We can use them diagramming. Trying to keep symbols as universal as possible helps make our diagrams and illustrations more accessible across teams and across people who work on the web in different places of the web. In the web development world, there are a few iconic pieces and symbols which are kind of representative cross-culturally and can help us with our basic diagramming. And these include like the home icon. Hearts are generally liking things or saving things. Refresh, the little arrows, that's a pretty universal symbol. Making things larger or smaller, like those pinch arrows. Downloading, battery indicators, settings, that's usually like the gear icon. Menu icons, you got like hamburgers, kebabs, I don't know, whatever food you want to include in there. When you do use these common symbols, you can pair them with color as well. So choosing color along with the symbols can help push their meaning even more, making it even easier to scan. So something like this is pretty universally understood that green is check or good or correct or create, and then red is not good, exit, cancel, erase, delete. It's also important to combine color with symbols if you are doing this, because people who are colorblind are not going to see the difference. They're just going to see what's on the left. The thing that I will say is don't combine these, like don't collide symbolic color. This just confuses everyone. If you're going to use color, make sure that you're using symbolic color. If not, just keep it all black and white. I've never used Keynote before, so I wanted to include that effect. I'm sure that this image is something that we're familiar with as well. But look how it's annotated. This is a ColdFront. Get it? But the important bits stand out. They use color to highlight areas. They use arrows to show directionality. They use text to annotate the image. And in the same way that you can annotate the weather, you can annotate code. This is an example from Sean Larkin. Webpack is generally known to be a confusing subject, especially setting up Webpack and organizing it. So he's done a lot of really good work where he's taken screenshots of code and visually annotated it using color and arrows and was able to combine different text sections to help people understand what's going on here and how those sections relate to other sections. This is better than code comments because you can separate them from what the rest of the code looks like and wrap them and use all these other techniques to help improve understanding. And you can take that a little bit further with diagramming entire concepts. This is the Webpack plugin system. So Sean did another great example here of a diagram where he just used these pluggable boxes and arrows to show you how this plugin system works. And it's a lot easier to look at this and understand a concept than it is to read an article about it just in blocks of text. Arrows are really powerful when you're diagramming. This is pretty much all you need. You can step cycle. So here we have like unhappy to happy. Maybe right triangles are bad or something. They can show cause and effect. So you can draw your own conclusions there. They can show directionality. Like these are my travel plans. And the arrows really help to convey meaning. Just a simple arrow can convey so much meaning. And then combining that with emojis, that's like cheating. But we have them now, so we should cheat. Don't let diagramming intimidate you. It's mostly just boxes and arrows. This is an awesome example. Who here watches Game of Thrones? Yes. If you haven't seen up to season 6, don't look at this diagram. It's a spoiler. But if you have, it's so cool. So HBO put this out, and it's an example of how all the families are related and who is what and relations, like in if there's like King's Garden here, there's like a lot going on. But it's presented in a really simple way, and it's mostly just arrows. It's photographs and arrows, and it shows directionality, and it shows who killed who and who's related to who, and it's really cool. So I love this diagram. It's 4,228 pages of text distilled into one diagram that we can parse in a few minutes. I read online that it would take you 73 hours and 28 minutes to read all of the book series up to now. We don't have to spend that much time on this diagram. So simplicity is key. An image is worth 1,000 words. Organizing things in a sequential manner alone can get a point across really well. I love this example from Ben yesterday where he visually showed us time to interactive along a timeline. And a lot of other speakers also included diagrams. I didn't even realize when I was writing this talk that, oh, of course, diagramming is great for speaking as well. I really liked Sam's example of layout engine with Houdini. There was a lot of cool examples of diagramming here on the stage, which really help us to understand what's going on. You don't want to watch a talk about just bullets and blocks of text. You want to see how things interact and how things work. This flowchart illustrates a basic GitHub concept of merging and checking changes. And so here it just shows a user flow. Is there any conflict? Yes or no? Get the latest version, merge changes, change things up so there aren't any conflicts, commit. It just shows like this architecture of that whole workflow. And it requires a few basic shapes and arrows. Using something like a flowchart can be really, really effective, and there are only 5 shapes that you need to know to understand the entire architecture diagram of this. And here those are. There's these 5 symbols. You have your start and stop, which is round or an oval, just to fit the text in there. You have arrows, and you can also include text within those arrows that are asking questions or making statements. You have parallelograms, which are your inputs and outputs. Your rectangles are your process. And then your diamonds are at a decision point. So diamonds usually have arrows that come out of them and have questions or directions or decisions that you're making. That's it. 5 shapes. We can all draw these shapes, but that's all you need to create a flowchart and allow for user flows. This is how Slack decides how to send notification. Having something like this is really, really powerful. It looks complex, but it would be even more complex if there was a book this thick about making that decision. It's a visualization. You could see you start and stop at various points. Yes and no is your ultimate decision. Do I send notification out? And this is all just a little tree. I don't know if you all got like teen girl magazines back in the day, but I definitely did. And it was like, which Backstreet Boy are you going to marry this week? This reminds me of that a little bit, but in a very adult way, of course. You can start to get a little bit more creative with this by introducing visual assets and illustrations. Here's a diagram of how blockchain works. You don't technically need illustration and iconography in there to prove the point. You don't need to present it in chart form. There's a really short 7-page white paper you can read. But presenting it this way makes it so much more understandable for us and so much more enjoyable. It makes you want to actually read this. Like, who here has read the blockchain white paper, the Bitcoin white paper? 1 person. 2 people, I applaud you. Let's talk later. But here we have visualizations that make it so much more understandable and enjoyable. At DigitalOcean, we have a pretty big community with blogs really aimed at developers and not just sysadmins. It's a cloud infrastructure company, so we want to kind of teach people how to set up their servers pretty effectively. And because we're not focused on sysadmins, we're focused on just anybody who wants to build a site and have a server run that's effective, we have diagrams that really help with our users' understanding of what's going on here visually. This is an example of a setup. So we have a load balancer here combined with a database server with monitoring, logging, and backups. And that's a pretty robust system. It's a pretty standard but robust system. When you explain something to somebody in a way that anybody can understand, like using these diagrams combined with text, it makes it more consumable for everyone. So even the sysadmins that are using DigitalOcean have a better experience because we're helping every user understand this. In a lot of situations, having diagrams is honestly just more effective than having text at all. People will probably open this, skim through it, skip the text, look at the diagram, and then read the text if they want. It really describes the text without having to have the text there. Subtle animations can also really help with your visualizations as well. This is a visualization of how load balancers work. So we have an active and passive load balancer. If that one, for some reason, stops working, you switch your floating IP, and then it continues to serve and balance load to the different servers or droplets that you have presented for your users and linked to that load balancer. Having this visual flow, this subtle animation, really helps to understand all of that without having to read an article or blog post or several of them on Stack Overflow and make mistakes. It's just a really nice way to kind of help explain what's going on. And this is also better than a video, too, because you don't have to sit and wait for it to load and watch the whole video of somebody speaking over this. It's just a very simple diagram that has these adorable subtle animations. VO even has icons and a style guide for creating these kinds of illustrations. And I love that. If you have a product that has an API or is open source that has a lot of different technical diagramming, like JavaScript frameworks, I think should have these sorts of things. I think that you would benefit from working with design to create elements such as this that people can use when they're implementing your framework or teaching people how to use your framework. And that brings me to tools. The tool that you just saw with all of those icons is called draw.io. This is a pretty powerful tool. It's free to use online. You can also download it and use it locally. And this allows you to create charts, flow charts, electric circuit diagrams, maps, tables, and it comes with a basic set of shapes and basic coloring tools. You can also create your own set that you can import in there and have as your sort of base elements. Is also this app called Cuckoo, which is kind of like a step up. There's a free tier, most of it's paid, but this really does, I love like the color that you see here. It has a little bit more integrated features. It's a little bit more robust than the other one. So if you are doing a lot of diagramming, check Cuckoo out. OmniGraffle is a really, really popular application as well that you can download locally and use for sort of user mapping and a lot of this like diagramming. This is something that my team uses that I see a lot, which is pretty cool. Like things like move around and connect, so you're not always redrawing things. And there's also a site called graphletopia.com that has a lot of free stencils for you to use and pull into OmniGraffle. On the left here is Atlassian's UI kit. So they also create a UI kit that they're sharing online for you to download for free. In the middle, we have mobile prototyping interactions, mind mapping tools. On the right, we have these web UI basics. You only get one download a month, but here's a pro tip. You get a free pro account if you share a stencil. So if you contribute back, you can get as many as you want. So contribute. I think that's a pretty cool like little incentive there. Another awesome free tool is called ASCIIflow.com. And this is like super, super basic, but you can draw with ASCII visually in your browser and then include arrows, include text, and then just like copy it and paste it. This is just text. You can pull it out as text, so I can like paste it onto this page and it's all highlightable. ASCIIflow.com is awesome if you're writing documentation. If you have READMEs that you want to also include diagrams in, you can create visual ASCII elements here. So I love this one. Y'all are the best. You read the slide. Okay, so the last thing I want to talk about is called Paper, and this is an iPad-only application, but what I like about it is it provides a variety of like tools that you can work with. So you can be more free-flowing with this to do this kind of diagramming. They also have created this set of tools that like help you to draw a straight line. So they'll like automatically convert it into a diamond or a circle for you if they think that's what you're drawing. And that just exists in the app itself now. It's one of the newer features. I use Procreate for whenever I'm doing the technical diagramming drawing that I will show a little bit later. And it's just because it's the same thing as Paper, really. It just has a little bit more freedom to it. And it's kind of more like Illustrator, Photoshop-y. So I like that. It's on my iPad. So we talked about diagramming a system for other people to use. We talked about basic elements and how to create diagrams. We talked about some tools for helping you build those diagrams. But now let's talk about diagramming for your own personal comprehension. I've learned that whenever I've created a diagram for my own understanding, it 100% of the time has always ended up benefiting other people as well. But for your own understanding, when it comes to learning and remembering a concept, I wouldn't recommend those tools that I kind of showed a second ago. I would recommend paper and pencil or one of those iPad tools where you can draw, or any other tablet where you can physically write things out. That method of writing it out helps you to remember. The act of writing is what helps you remember there. Here's the thing about tech. I think sometimes we get so caught up in our understanding of a subject, our technical understanding, especially people who are project maintainers, that we forget how to go over the big picture in the first place, because there are so many details and tangents that we want to go down that we think are important because they're important to us in the present time. So we'll just write some prose and demo examples that make sense to us in our intended use cases, that make sense to us where we are in the process, and share those. Using diagramming is a great way to take a step back and show someone the big picture. It's also a great way for you to understand that big picture for the first time. The more knowledge somebody's acquired about a subject, the harder it is for them to relate to somebody who's new and who's learning it for the first time. So that's another reason why it's really important to take a step back and think about that perspective of your audience. How many of you here have had less than 3 years of experience in this field? Oh, not that many. Those people, tell those people, talk to your junior engineers if they're not here. Tell them that we need them to start taking notes and sharing those notes and to start experimenting and becoming the teachers. It's really important for them to do that. So as you're teaching someone, teach them to also teach. Because teaching general concepts becomes harder with more advanced domain expertise, we need developers who aren't writing the frameworks to be writing the documentation, to be contributing to open source in that way. When you write blog posts and produce educational content, you can learn. You can learn while you're teaching. You understand what's important also and what's not to somebody who might be in that stage, and you know what holes need filling. So if you're getting started in this field, if you know someone else who is, give them that advice. People ask me all the time, like, how do you end up speaking on a stage? The way I started here was just doing that, like writing blog posts, doing experiments, sharing those blog posts, teaching as I was learning. I created this really colorful diagram of event flows at DigitalOcean that I can't really show you, but look how pretty. So I created this for my own understanding when I joined a team that was more horizontal in the front-end infrastructure space. And it really helped me to understand how events propagated throughout the entire system from the visual layer to the hardware. Like, how was that working? How were these droplets working? So when I created this diagram, kind of word got out. People wanted it. People wanted to share it. I put it up on a place everyone could access it. And it helped engineers who have been at the company for so much longer, who understood the entire infrastructure layer, but they didn't realize that there might be some other thing here. They didn't realize how something may be working in another part of the company. Having things like this really helps with understanding of how your application works. It also helps because it's that visuospatial scratchpad, which means that engineers don't have to keep all of it stored in their own heads. They don't have to keep all this knowledge in their heads at any given time. You can pair diagram and create things like this. And diagrams are also a really good way to discover bugs and inconsistencies. You could discover things that don't really fit properly. So having this entire systems architecture diagram is a really great thing I would recommend to any company or any project. Let's talk about mnemonics. Mnemonics are great. Mnemonic devices are a great way to help you remember concepts as well. A mnemonic device is defined as simply a device that aids the memorization of something else. It's a really broad definition. But there are 9 basic types of mnemonics. There is the music mnemonics, like jingles. Do you all have phone number jingles from commercials or radio that you remember? We have one for a mattress commercial that I'll never forget. It's 877-241 Luna. I'm never going to forget the phone number to this mattress company. Why? It just exists in my head for no reason. Why can't I remember other things, like syntax that I care about? So the second way to remember things is through names. This is another mnemonic device. So Roy G. Biv, where I grew up, is a way to remember the colors of the alphabet: red, orange, yellow, green, blue, indigo, violet. And that's kind of just a Roy G. Biv. That's how I remembered it. Expressions and words. So PEMDAS is the order of operations. So what we would do to remember this is, please excuse my dear Aunt Sally. It's kind of like how we remembered it. It's obscure. All these are a little bit obscure, but it's parentheses, exponents, multiplication, division, addition, subtraction. The next type of mnemonic is a model. So in the US, we have this food pyramid, and now we have a food plate that shows you what kind of portions you should be eating and what kinds of foods you should be eating. It's this visual model of that item. Odes and rhymes are another mnemonic device. So in 1492, Columbus sailed the ocean blue is the year that Columbus discovered the Americas. The next one is actually notes and organization. Note cards are a mnemonic device. This is a way to distill information and pair it with another item of information. So you can use note cards as a mnemonic device. Images, creating image associations in your notes, are an example of mnemonic devices. I'll show you an example of that in a minute. And making connections, longitude goes from north to south because there's an N in the word longitude versus latitude. So mnemonic devices are great. The last one is spelling. There's a river in the US called the Mississippi River that everyone misspelled. So they created this like rhyme that goes, it's not a rhyme, it's like a little M-I-S-S-I-S-S-I-P-P-I. And then you'd have contests with your friends to see who could say it the fastest, like M-I-S-S-I-S-S-I-P-P-I. And so it was like really cool in first grade. I don't know. Speaking of mnemonics, I was recently on Suze Hinton's Twitch stream, which is awesome, by the way, if you're interested in JavaScript and electronics. She does these almost every Sunday at around 1 p.m. Eastern time. So I was on there just kind of learning about this subject, and I decided to bring my iPad and start diagramming and creating some like illustration as I was learning about it. So she taught me a little bit a mnemonic about anodes and cathodes and how to differentiate between which one had the longer versus shorter lead. This was the illustration that I came up with. It's this like pretty summed up LED hello world. And so her way to remember anode and cathode was anode is A+, A+ student, positive, reach for the stars, longer lead. And then the cathode is the C, so C-, the shorter lead, like do better in school, you're coming up short. So this is just the entire diagram from that. I mixed code in with the diagram. And then again, I shared it on the internet and people liked it. This person's like, I just tried it. It's as easy as it looks. So the 2.5-hour session we had could be distilled into like a diagram. It makes things a lot more approachable. So here are some more examples of how mnemonics can help with comprehension. These are some of those dev tools that I created. This first one is about the spread operator. So the spread operator is that ... which really helps with a variety of use cases. In this case, I was showing spreading a string into multiple components of that string. So with the spread operator, if you use it ... that variable coyote inside of the array, it spreads out into the COYOTE. It breaks it up into all the letters in that string. So I imagine this like a spelling bee, like somebody saying, okay, spell coyote. And this person's like, ... Okay, and then you put it into the array, ... coyote, COYOTE. So it's like one little way to remember it with like this story, this imagery. This is one about JavaScript promises and using fetch. So the way that I remember this is thinking about like an IOU letter. So here we're saying fetch a link to my rent money, right? So the fetch just returns a promise. It's not actually returning any data. It's not returning your money to you. This is returning a promise that the rent money will get paid to you. And then you can go through two different options here. So okay, if it goes through, okay, got it. Then you can set the tenant status to rent paid, and then you can get the data through that, and you can send the data through. If you don't have the rent money, then you catch it with your status being warning sent. So it's like another situational thing, combining visuals and story to remember promises. The way that I remember array.map is by using the letters of map to spell out morph array piece by piece. So in this example, we have this array that's containing 1, 3, and 4. If we use array.map, we have our value and we have our transformation. So we go through each value in that array and we transform it piece by piece. We morph that array piece by piece to create the next array. The output is 2, 4, 5. We're just adding 1 to all of it. So map can be remembered as morph array piece by piece. This is a concept that existed when ES6 variables came out, so let and const. So what happened before with var is you would have, what's it called? That thing where variables kind of flow to the top of the document. Hoisting, variable hoisting. Right, so variable hoisting doesn't exist when you use let and const. So you have this area that will throw an error, which is called the temporal dead zone. There's a term for it if you try to use that variable before it's called within that function. And we didn't have that with normal JavaScript variables. So a way to remember the temporal dead zone is through this imagery. The last example I have is the for in versus the for of loop. The for of loop is also one of the newer ES6 functions for us. So here, the way I remember is for in gives you the index. If we have this variable of pets, we have Lola, Mandy, and Rex. If we say for let pet in pets, we return the index 0, 1, and 2. If we console log the specific pet out. When we say for let pet of pets, it's the object, not necessarily an object, but it's not the index. So we get Lola, Mandy, Rex, all the other pets individually. So that's the way that I remember this. I use the word itself to create an association and help remember. You can also use diagramming to sort of keep things straight and create a shared language. Again, like we forget about note-taking, but sometimes note-taking and sharing those notes is really effective. A lot of the time, people kind of argue about what different types of tests mean and examples of those tests. So when you combine that with examples and names, we put these in our documentation when it comes to like getting started with working on our front-end application, just to keep it straight. And people liked it. People liked having this visualization along with the text of what these different tests mean, how to get started with them, just so they could kind of understand and see it from a bigger picture. So that leads me to doodling. Doodling helps you to think through, understand, and remember concepts. The physical act of writing, again, is more effective for memory retention than just typing is. Plus, it's a shorthand way to form connections between concepts, so both physically on paper and then mentally in your mind. Sketchnoting is a really awesome example of this. This is a really, really beautiful one. I love seeing Chiyuki's sketchnotes. You can find her online at Chiyuki. And she was doing sketchnotes about how network works. And it was a talk by Amy, who does all the bubble sort scene stuff. But she uses a variety of different tools here. Color, she uses diagramming. She uses like this little box set that kind of compares and connects throughout. She uses illustrations, like this image. She uses bubbles, hierarchy here. So that's cool to see. I also really love Susan Lynn's sketchnotes. She does a really good job of this too. Sometimes she goes to conferences and does sketchnotes of all the talks. I love seeing this. Here's another example from ClarityConf that combines color. This was a talk about color, so having sketchnotes really helps to sort of push this point across even further. And here, Brian Frisch, I don't know where you are, Brian, but I love your sketchnotes. This is from, hi, Brian. He's on the beanbags. Hey, give Brian a round of applause, man. These are cool. This is another one from yesterday. So I love seeing this. Even though I keep all of my appointments in a digital calendar, when my schedule gets really crazy, I find that writing it out in a notebook really helps me to remember. So there's this popular approach called bullet journaling, and that's a specific system that helps you create your own spreads and lets you like build upon it really easily. And we'll talk about that later because I'm running out of time, but I love bullet journaling. Let's chat about that, also about crypto. But I do this with all my side projects too. If I come up with an idea, then I want to write it out, draw it out, have it somewhere physically, and that turns into full projects really easily. Like you don't have to get super complex. You can just include a few lines of text, maybe some color to differentiate different areas, and you can have all of your thoughts down. When you write, you learn. When you learn, you can teach. When you teach, you reinforce the concepts that you've learned. So it's really this positive cycle. So doodle for yourself if for nobody else. Writing and doodling is an overlooked tool for developers. If we go back to this idea of memory, you can use doodling and physical writing as this visuospatial scratchpad for all the things that we can't keep in our head. When we return to these ideas, we reinforce them in our working memory, which will help convert them into long-term memory, and that's the goal. Writing things down also decreases the stress of, oh my gosh, there's so much going on, I can't remember all these things, I have appointments, I have like people to deal with, I have meetings to make, I have tickets to create. Writing things down helps with all that. Like, I live by to-do lists. So don't be afraid to take handwritten notes, and don't be afraid to doodle. Even if you think you're not good at drawing or writing, still practice. Nobody has to see it. I think if you do share it, it'll help people, but do it for yourself. So some final words to take home. These are just some little quick sketch tips for devs. One thing I want to note here is if you're drawing text versus code, remember the indentation. That's like the only difference, and it makes the big difference. So that's kind of how to differentiate that. People usually look at that and like, oh, yeah, that makes sense. So the first thing I want to say is use doodling and diagramming as a learning and teaching tool. Chunk content. Keep your content short and keep it readable. Use imagery paired with color and basic symbols. Arrows and boxes are often all you need. That's usually it. Take notes again by hand and share what you've learned. If you did write some notes in front of you, if you did some doodling here, share those. Share those on Twitter. Share those with the conference hashtag. I think it's ColdFront17. It'll be fun to see what we all did and just put them all together. And I'll be sure to check those out. So thank you.